Okay, we're going to talk about statistical inference hypothesis testing. In this topic, we're going to introduce you 3 different approaches, okay? And the first approach and the second approach. These two, you already see in the early one, posting of YouTube video. And the one I'm going to cover this class is the third approach. The third approach, I call it p-value approach. And the p-value approach is an approach used by our textbook, okay? Now, hypothesis testing, p-value approach. Recall our experiment. A coin is flipped 100 times and we see 40 heads. Based on this correct evidence, we're going to make inference on the coin. Is a fair coin or not a fair coin? Or you say the coin is biased, okay? So the first step in hypothesis testing, we're going to set up hypothesis. In hypothesis testing, there are 2 hypotheses we wanted to set up, okay? H0, no hypothesis. We say the coin is a fair coin. Or we can express a hypothesis in terms of population parameter. Or you can say H0, the null hypothesis. Pi is equal to 1/2. This is 50%. And what's pi? Pi is a probability of getting heads. Pi is a probability of getting heads. If you have 50% chance of getting heads, that means you have 50% chance of getting tails. 50-50. That's why we call this is a fair coin, okay? Now, alternative hypothesis, HA, alternative. A comes from what? The first letter of alternative, okay? A. HA always say H0 is not true. So in hypothesis testing, you can have only one hypothesis true, because these 2 hypotheses always against each other. So you cannot have both true. You can have only one true, okay? Having said that, H0 is not true, okay? Let's see how we're going to set up what? How we're going to set up our alternative hypothesis. This is not true. H0 is not true. This is not true because 1, pi is not equal to 50%. Or you say H0 is not true because pi is greater than 50%. Or you say this is not true because pi is less than what? 50%. When you choose not equal, we call this is 2-sided alternative. Okay, we call this a 2-sided alternative. And this one, just what? 1-sided alternative. And which alternative hypothesis we're going to choose depends on our research interest, okay? So for that reason, HA, the alternative hypothesis, people also call it research hypothesis. Because this is a hypothesis, we place our research interest here, okay? And H naught, so some people also call this is what? H1, okay, H1. Remarks. Commonly made mistake in setting hypothesis, okay? From time to time, I find people set up hypotheses like this. It's not. They put what? X bar, okay? X bar is equal to 1/2. And against HA, X bar is not equal to 1/2, okay? This is wrong. Why this is wrong? X bar is the sample what? Is the sample statistics. Okay, X bar is a sample statistic. Sample statistic depends on sample. They change what? All the time. If I get 50 hits, this is 50%. If I get 75 hits, this is 75%. If I get 30 hits, this is what? 30%. So when we make statistical inference, we are not infer what? X bar. We are not infer sample statistic. We infer population parameter. We want to infer population parameters. Not sample statistic. Not sample statistic, okay? Because sample statistic depends on sample, they change all the time, okay? So we want to infer population parameter, not sample statistic. Second one, based on research interest, we choose what? We choose our HA, okay? As I mentioned earlier, do not choose HA based on collected data. Some people may say, okay, I flip the coin 100 times, I see 40 heads. So the sample percentage, 40 over 100, is 40%. And 40% is a number less than 1/2. So I'm going to choose what? The third one, pi less than 1/2. This is what? Huh? Based on this, you choose what? Pi less than 1/2 as your alternative hypothesis. This concept is wrong, okay? You should choose your HA based on your research interest, not based on what? What you observe on the collect data, okay? Say our research interest is we want to know the coin is what? Not a fair coin in the sense that it's not equal to 50%. We choose this one based on our research interest, not based on the collect data. Is that clear? Okay. Now, the third one, equality should be included in what? In H naught. From time to time, I find people set up hypotheses like this. They say H naught pi not equal to what? 1/2 against HA pi equal to 1/2. This is wrong because equal sign should always in what? H naught. So these two hypotheses, you want to what? Swap, okay? So H naught should be pi equal to 1/2, and HA should be pi not equal to 1/2, okay? And give you one more example. This is also wrong because this equal sign, you probably want to put it here, okay? So far, so good, okay? This one should be swapped, okay? Should be swapped. Equal sign should always include it in what? In H naught, okay? Now, let's flip to the next page. Step 2. Choose a level of significance level, alpha. Usually, alpha equal to 5% or alpha equal to 1%. A very small one, probability, okay? This is a small probability. Why we choose a small probability? The reason will become clear as we go on to discuss this topic, okay? Now, what's alpha? Alpha is the probability of making type 1 error. And what's type 1 error? Let's look at the definition. If we reject H naught, when in fact H naught is true, this is a type 1 error, okay? If we fail to reject H naught, when in fact H naught is false, this is a type 2 error, okay? And usually type 1 error is the more serious one error, okay? Since type 1 error is a more serious mistake, so we want to choose what? A strategy we can minimize the chance of making what? The more serious mistake. Since alpha is a probability of making type 1 error, so we allow a very small chance to make the more serious mistake, okay? That's why alpha usually is 5% or 1%, okay? Now, to make you better understand the concept of type 1 error and type 2 error, let me give you an example, okay? Let me give you an example. Suppose, say Peter is suspected of killing what? His wife. And suppose you were the judge, okay? Then there are two possible mistakes you can make. Okay? If you were the judge, then there were two possible mistakes that you can make. The first mistake, okay? Peter is what? Peter is innocent. Peter is innocent, but all collected data strongly against him. So, as a judge, you send what? Him to electrical chair. Okay? What mistake is this? The mistake is you kill an innocent person. Okay? You kill an innocent person. That's the first mistake you can make as a judge. The second mistake is Peter is what? Peter is guilty. But collected data are not strong enough. So, so you set him free. What mistake is this? The mistake is you free a criminal. Now, let's compare these two. Which one is more serious mistake? You kill an innocent person is more serious, or you free a criminal is the most serious mistake? Okay? Hypothesis testing will not tell you which one is what, more serious mistake. But whichever you think is more serious, that is your type 1 error. Okay? That's your type 1 error. From hypothesis testing what? Framework. You choose the one you think is a more serious mistake, and you call that one is what? You call that one is type 1 error. Okay? Suppose you are a kind person, just like a Scott. You think the kill an innocent person is a more serious mistake. Then this will be your type 1 error. Okay? But if you think, if you free a criminal, then there will be more a victim got killed. Then you can say this one, you free of a criminal as what? The more serious mistake. Before we further discuss the detail, let's think about this question. Okay? Can you tell me a strategy that I will never make this mistake? Think about it. Think for what? Couple seconds. Okay? Think about a strategy that you will never kill an innocent person. Okay? I think you already figured out, right? If this is your strategy, you will never kill an innocent person. That is, whoever sent to the court for that reason, you say, I don't believe anybody will kill what? His own wife. You free everybody. If you free everybody, if that's your strategy, then probability that you kill an innocent person, that chance is 0. But on the other hand, the chance you make this mistake when what? Peter is actually guilty. You make this mistake, that's 100%. Okay? Now, let's come to here. Think for another what? 10 seconds. What kind of strategy you use so you will never make what? This mistake. You will not free a criminal. Think for 10 seconds. Okay? So, I think your answer probably what? The same as mine. Okay? If you use the strategy, right? Whoever sent to the court for that reason, you say, you don't even ask. You just kill them all, right? You kill everybody sent the court for that reason. Then you will never free a criminal. But on the other hand, when the person is innocent, with probability 100%, you're going to make this mistake. As you can see, the both strategy, either you free everybody or you kill everybody. Those are best strategy. So, so this is what we use in our Huh? Our daily life wisdom. When you see two devils, you try to figure out which one is more evil. And you're going to find out a strategy to minimize the chance of what? Making the more serious mistake. So that's why, come back to our early talk. Okay, you look at these two mistakes and you ask yourself, which one is more serious mistake? And you're going to find a way to minimize the chance of making what? The more serious mistake. Say, if you are a kind person, just like Scott, you think kill innocent person is a more serious mistake. You choose this one as what? Huh? As a more serious mistake. Then this one should be your type 1 error. Okay? If you think killing an innocent person is the more serious mistake, then this is your type 1 error. Okay? So let's look at the other two, the following two settings. The first set of hypothesis testing. H naught, Peter is guilty. Against HA, Peter is innocent. And set 2, second set, okay? You say H naught, Peter is innocent. Against HA, Peter is what? Peter is guilty. Which set you should use to test the hypothesis? Okay, so let's look at here. If you think killing an innocent person is a more serious what mistake, then this is your type 1 error. Remember what's alpha? Huh? What's probability of making type 1 error? Your type 1 error is a probability that when Peter is what? When Peter is innocent. And you don't believe he's innocent, you still send him to what? Send him to electrical chair. In this case, you kill an innocent person. Remember, what's type 1 error? Type 1 error says what? Under the assumption that H naught is what? Is true. But you reject H naught. Remember, this is more serious mistake. If you believe when Peter is innocent and you kill an innocent person, if you believe kill an innocent person is a more serious mistake. When Peter is innocent, under H naught is true, you send me to electric chair, you reject H naught. That's more serious mistake. So in this case, the set of hypothesis testing you're going to use is set 2. Okay, is set 2. And when you're going to use set 1, well, if you think free a criminal is a more serious mistake, then you should choose what? You should choose set 1. You should not choose set 2. Is that okay? So which one you're going to choose as H naught, which one you're going to choose HA, is not choose arbitrarily. There is a reason behind it, and the reason is you set the more serious mistake as your type 1 error, and because this is more serious mistake, so this is your alpha. That's why alpha is a very small chance, right? Usually it's 5%. If you think 5% chance of making more serious mistake, that chance is still too big, then some people may want to choose 1%, okay? Let me summarize again, okay? To put down the hypothesis in H0 and H8, you are not arbitrarily assigned. There is a reason behind it. And what is that reason? Well, beginning from what? Hypothesis testing framework. The more serious mistake is a type 1 error. Okay? And the definition of type 1 error is under H0 is true, you reject H0. So if you believe killing an innocent person is a more serious mistake, look at the setting here. When Peter is innocent, you send him to electric chair. You kill an innocent person. This is more serious mistake. So when Peter is innocent, you send him in the electrical chair. You kill an innocent person. So you should choose step 2. Okay? Since this is more serious mistake, we allow a very small chance to make the more serious mistake. And that chance is only what? That chance is only 5%. That is to say, unless collected evidence are super strong, right? Otherwise, you just what? You just free everybody, right? Unless the correct data are super strong against what? Peter. So on the other hand, you are more likely to make what? The mistake. You're more likely to what? To free a criminal, okay? But that's fine, because in your opinion or in your situation or your position, free a criminal is a mistake, but it's not as serious as what? Kill an innocent person, okay? Not as serious as killing an innocent person, okay?